Once again, warm greetings to everyone. So, this session I'm going to be talking about a proposal to improve motion compensated spatiotemporal filtering in X265. So, I'll provide a brief introduction to MCSTF and the steps involved in it, and then I'll discuss in detail about the proposed solution. Finally, cover the experiments and the results. In my previous session, I gave an introduction to video codecs and X265, so I'll straight away talk about MCSTF. MCSTF is a spatiotemporal filter that is applied only at the encoder as a pre-processing step. It helps in increasing the overall compression efficiency, and it's useful particularly for noisy videos that are generated with camera. They're not much useful for computer generated animations. Generally, any compression algorithm makes use of the fact that there is a lot of redundancy between consecutive frames in a video. The extent to which compression applies ultimately is derived by the QP. So, adapting the QP at the block level, making use of only the spatial complexity is a suboptimal solution. MCSTF tries to overcome this drawback by making use of both spatial and temporal complexity values, and it does a temporal filtering. In HM, MCSTF is incorporated, and it's been applied only to the first picture of every GOP. MCSTF involves multiple steps. The first thing is to arrive at a reference window consisting of past and future frames from the current one. Once we generate the reference window, we need to perform motion search using all of the past and the future frames in the reference list, and then we generate multiple motion compensated pictures for using each of the past and future frames. After that, we apply a temporal filtering. In X265, we apply temporal filtering to each of the INP frames. The filter strength depends on the correlation between the current frame and the reference frame. As the correlation drops, the strength also drops. Typically in MCSTF, there are three major steps. The first is the hierarchical motion estimation, then the motion compensation, and finally the temporal filtering. So, as I told earlier, we need to generate a reference window. Like shown in the diagram, for the central picture represented as 0, we need to pick 2 past frames and 2 future frames. In the case of first I frame, we select only 2 future frames. Once we have the reference window, we apply motion estimation between the central picture and each of the reference frames available, and then we generate multiple motion compensated images, and ultimately we produce one filtered image which is noise removed. This is the flowchart for the hierarchical motion estimation. First, we need to generate subsampled images for all the pictures, including the current and the reference pictures. Here, L0 refers to the original resolution of the image, from which we derive at the subsampled image L1, which is quarter resolution of L0. We use the same subsampling method to arrive at L2, which is again a quarter resolution of L1 image. Then we apply motion estimation for each of the 16 by 16 block in L2 level, and the best motion vector arrived at L2 is used as the starting point for motion estimation in L1. Similarly, we take the best motion vector from the L1 image and apply it as the starting point for the motion estimation in L0 image. And ultimately, we do subpixel motion estimation for each of the 8 by 8 blocks at the original resolution level, or L0. After hierarchical motion estimation, we move on to doing the motion compensation. In our use case, we actually generate totally 4 motion compensated images using all of the reference frames, and then we apply an interpolation filter to each of the current pixels. The interpolation filter is applied using the formula that I've shown here. This is nothing but a weighted average of the current pixel and some of the co-located pixels in each of the motion compensated prediction. So we conducted experiments in X265 comparing with and without MCSTF using CRF values 24 to 27 at medium preset for random access configuration and intra-period of 250 frames. To enable MCSTF, we need to add an additional option -MCSTF. These are the set of sequences that we used: 1080p 60 FPS and video length ranging from 5 seconds to 50 seconds approximately. For the test sequences, 1080p 8-bit sequences, on an average we were able to observe around 8.2% bitrate savings in X265 for the medium preset use case. Similarly, for the 10-bit video sequences, on an average we were able to observe around 10.5% bitrate savings in X265. We conducted another set of experiment using both 1080p and 4K sequences, 60 FPS. This is mainly to compare the relative gain that we see in X265 and the relative gain that was observed in HM. So in X265, with and without MCSTF for 4 different CQP values, 22, 27, 32, 37, for very slow preset were tested, and on an average we were able to observe around 19.5% bitrate savings in X265 at very slow preset. We ran the same set of tests with HM 16.2 version, CQP 22 to 37. Here the overall or the average coding efficiency gain was around 6.9%. So in conclusion, MCSTF is an temporal only, is an encoder only temporal filter applied during pre-processing. It is overall used to reduce the noise in the video sequence, and the novel MCSTF algorithm that we proposed has a better coding efficiency gain compared to HM, and overall it helps us to improve the compression efficiency. And one point that I have not discussed here is the computational complexity that MCSTF introduces. So we are doing benchmarking and trying to understand and explore this further. Thank you.
Okay, thank you. Any questions?
Is there any schedule of the release of the coding X265? Looks very interesting work. Is there any schedule to release the source code in X265?
This code is available in open source.
It's already okay.
Yeah.
Okay. Thanks.
Any other questions?
Is that in principle the same as for an HM model from MCTF?
Yeah, overall in principle it's same, but in HM it's applied only for the first picture in every GOP, but in X265 we are applying it for every INP picture.
Sorry, for every?
INP picture.
Oh, okay, that makes sense. Thank you.